Hi, my name's Mark and I'm going to be talking to you about the project that you're going to be doing with the BBCMicroBit and hopefully using it as a data logger. So to begin with, the first thing we need to do is to download the Mu editor. This is quite important because we're going to be using Python on the BBCMicroBit, and unfortunately the latest version of Python isn't available on the web editor yet. So to get the latest version you have to download this specific editor, which we'll do now. So the first thing is, if you go to the BBCMicroBit web page, and just click on the search item and then just have a search for software tools. Then the first thing it gets you to is this lesson, and when you scroll down to the bottom of this you can see the Mu editor and there's a convenient link. Then there's options of basically which one you want to download this from. For Windows, Mac or Linux, download the one that you want, and then you can play with that. It's a relatively simple editor to install. I'm not going to go into it in any much more detail than that. Once you've finished that and once you've got that downloaded, what you'll be left with is you should, when you run up an editor, you'll look like something like this. To create a new project, we just click the New button at the top here, and then to begin with we're going to have a look at one of the standard things that we do in pretty much any software, and that is we're going to look at the documentation. If you start typing in BBCMicroBit and Python guide, you'll get this MicroPython guide, and the option that we want to choose on here is Hello World in the Hello World section. Now Hello World is the classic thing that we always write in any software project, which lets us know where things are working or not. So this is also a great place to get information and other little bits that you can copy and paste. A lot of software development is copying and pasting and then editing, so I'm just going to copy that and I'm going to go back into my editor and I'm going to paste that in. The little star up here shows us that we haven't saved yet, so Control S will save this. I'm just going to put it in here and I'm going to call it logger. I'm just going to save, and then we can press this button here and this flashes the code onto the BBCMicroBit. So I've got my microbit connected on a USB lead, so if I flush this, then what you see is on the back of your microbit, hopefully you can see that, there is a light flashing very quickly, and once it's finished flashing then you get a little screen popping up. Just close that down, but you should start seeing on here, and if I press the reset button, which is the one on the back, you should start seeing it saying Hello World scrolling across on the little LED patch at the front. So that's basically us set up with our microbit, our editor, so we're using the Mu editor, and everything ready for us to go to start making a data logger. So what I'm going to do now is give you a bit of a more in-depth description of the project we're going to do. So we're going to use the microbit that you've already seen, and we're going to use this to record the accelerometer readings. So on the back of the microbit, very nicely labelled for us to see, you can see one of the sections, maybe you can see it on there, one of the little chips on there is the accelerometer, and that basically tells us how much acceleration, how much force is being exerted on the microbit. That's great because it allows us to tell which way is down, but it also allows us to look at things like if it's being shaken or turned upside down and things like this. The main thing we're going to do is we're going to record those readings, and then, as with many data acquisition systems and data logging, what we want to do is the logging section of that is writing that data into a file. Now the microbit doesn't have a massive amount of storage on board. We can still write a reasonably sized file, which gives us a good idea of what's going on. And finally we want to tie this up into something that's reasonably convenient to use, so we want to do that when a button is pressed. And that's going to introduce us to most of the main concepts of the software development that we're doing. So now we're going to move on to the main sort of software. So we're going to take the program we've already written, and we're now going to modify this to become our data logger. And the first thing we need to do is set up the main, we call it an event loop normally, but this is basically the main sort of loop that sits around the entire application and keeps it running. And to do that, we're going to use a nice construct called a while loop. And a while loop is pretty straightforward. So we're going to delete our hello world and we're going to put in this while loop. Now, the first thing this does, while true, basically says just keep going. So normally while could say something like while this value is greater than that value, or while this value is equal to that value. But in this case we're just saying while true. So while this is true, keep going, and it is always true. And this is essentially just a classic way of setting up a loop. Now the first thing we want to do is we want to prompt the user to press a button. So the button element is the first bit we're doing. And to do that, we're basically just going to show an image, and the arrow image is going to point to the button we want them to press. Hopefully prompt them and remind them. Now what you can see here is this indenting that's going on here. Now what that means is anything that's indented is inside this while loop. So while this is true, display this image, then go back to the while loop and then display the image again and round. So this will run as fast as it possibly can, simply displaying that image again and again. Effectively we wouldn't see anything apart from that image being displayed. So what we now want to do is we want to add the option that says basically wait for the button to be pressed. And to do that we use a second while true loop. And what we do with this one is we basically set it up after this first bit is done. So we now say wait for the button to be pressed. So an additional while true loop, and we say if button A dot is pressed, and that basically says if the button A, dots are methods on that. So button A is the item that represents the button in our software, and is pressed is one of the methods that you can call on that. And is pressed basically returns true or false depending on whether the button is pressed. So if the button is pressed, then we break. Now what break does is it exits us from the most sort of current while loop we're in. So what this basically does is it says while this is true, display an image, wait for the button to be pressed. This will loop around really quickly, and nothing will happen if the button is not pressed. But if the button does get pressed, then essentially this will break, which takes us back out into the main loop. And this you can see once again the indenting. The if statement, what happens in the if statement is indented. Now we want to basically see what's happened. We're going to say, so what happens when the button is pressed. So this will stay running around here until the button is pressed, and when the button is pressed it will move into this bit of code. It will go down here, and so we let them know that the recording is ongoing. So we display the happy smiley face image on the thing, and for now, rather than writing any additional code, we'll use sleep, and we'll sleep for 1000 milliseconds, so that's a second. And what this will enable us to do is this will enable us to flash the code to our microbit. You can see this going now, and then what we should be able to see is once this is flashed, we now have this arrow pointing to the right, and then when I press the button you'll basically see a smiley face appear, hopefully. Let's just check that works. Yep, so you see a smiley face for about a second and then it goes back. So that's the equivalent of us pressing the record button. Now you notice it goes back to the arrow afterwards, and that's because we're essentially in this bigger loop. So while true is going on, it displays the arrow, waits for the button to be pressed, we press the button, it then shows the image, sleeps for 1000 seconds, and then goes back round into the next iteration of this loop, which displays the arrow again and waits for the button to be pressed. So as I say, that's what the kind of the main event loop is doing. And this is kind of a classic sort of setup that we'd use for any kind of work like this, where we want something to happen that we can process regularly. So now we've got our main loop working and we've got our button that's setting off the recording. What we actually want to do is now record that information into a file. And so to do that we have to do a couple of things. The first thing we have to do, unfortunately, as I say, the BBCMicroBit isn't the best bit of kit for doing some of the file system. It's not really designed to. It's a little tiny chip on a board, so the only memory that's available is the sort of the flash memory that's on board the chip itself. So the guys who do the Python implementation have really nicely faked up an operating system that pretends it's a file system, but it's not quite as good as it could be. So what we do is, first thing we do is we actually use an excellent thing, which is a piece of error handling code, which is a try-catch statement or a try-except statement. And what this does is it basically says, try to remove the file output.csv. And if you can't, then pass. This is simply there because at the very beginning of the first time you run this, the output.csv file isn't there, so we want to try to do it, but when we can't, we just want to ignore it. Pass does nothing. Every other time we want to do this, we basically destroy this output.csv after you've pressed the button. That means that any time you want to re-record, it means it clears out all of the flash memory on the microbit, free to record a separate thing. So now that we've cleared everything out, the next thing we want to do is actually open our file. Now, one of the things that's quite nice with Python, and I really like it, is the with statement. And with is a really convenient thing. It makes use of Python's indenting. So normally what you'd have to do is you'd have to say open a file, and then at the end you'd have to remember to close it. Now what this allows us to do is it just says with this file, with opened file, then we can basically do all kinds of things, and as soon as we've stopped doing them, Python will close it for us automatically. It will tidy everything up. So what we're going to do is we're basically going to say with open opens a file, output.csv, the file that we've deleted previously. The W says that I'm opening it to write. If you open with an R, it opens to read. You can only read from it. We're opening to write, which means we can put information into that file. And we're going to write the file header in there. Now, what we've explicitly said here is we've used the term CSV. That stands for comma separated variable or comma separated values. The reason we use that is because it's an excellent way of getting existing software to read our files, so we don't have to do any more hard work after we've written it. And what we're doing is we're then setting up a header which says what we're going to put in. The first value we want to put in, the first sort of column in our table, is time, followed by the x acceleration, the y acceleration, and then the z acceleration. And this is pretty much it. If we now flash this to our microbit again, so you can see the light showing that that's being flashed on there, and then once that's been flashed on, we press the button as we would before, and we get a smiley face for a little bit, and then we get the button back. Now we can use an excellent option in here which will allow us to access that file. So if I use the excellent feature of this, if I open up the files tab, then you can see files that are on my microbit and files that are on my computer. If I drag this across onto here, then it will copy the file across onto my computer. If you open up the directory that's associated with that, and you can see it's in your user sort of location in Python. You can also just search for it on your computer. If you call it like output.csv, you probably won't have another one like that on there. The nice thing is you notice that Excel has already picked this up. If you're on Linux or Mac, the appropriate other tool, spreadsheet tool, will probably pick it up. And if you double click on it, it opens it. and you can see it already populates the appropriate cells with time, X, Y and Z. So that's the initial work that we have to do to get files collected on the BBCMicroBit and to remove them from there using the files bar. The final piece of work we need to do in the software is to record the information off the accelerometers from the microbit, and then to use that information and record that into the file. We also need to set up another loop that basically records that information again and again and again. So let's start by setting up a couple of parameters that we want to use. These are just useful to have at the top of your program so that things work nicely. Now I've actually just noticed that I missed an import previously, but because I only ran things once it wasn't a problem. You'd have noticed this, it would have come up with an error. But I need to import OS, which I actually used in this section down here, os.remove. Now I forgot that. If you just go straight to the code you obviously won't hit that problem. It was just because I was building it up. The next thing I want to add is some default parameters. Now as I say, these are basically to make your life a bit easier, so there's one place to change things, because this will vary depending on what kind of thing you're trying to log. Max frames of 300 is about how much the microbit itself can actually maintain. The poll time of 100 is basically that's sampling at 10 Hz, so 100 milliseconds between attempted reads of the accelerometers. You can reduce that, you can probably reduce it down to about 10, 15, that kind of thing. It's about as fast as the microbit can go. That's quite nice, it gives you about 100 Hz measurement. You can obviously make it a lot slower if you want to. As I said, this is once again a basic implementation, but you can only ever store about 300 points. So if you want to record for longer, you need to up your poll time. The reason we declare them up there, as I say, is to make life easier, but we're actually going to use them down here. And we're going to create a new item, which is the main recording loop. So you can see how this works. So with the file still open, so we're still indented into this point, what we do is we set a value called count, and we basically say while count is less than max frames. Now max frames is the value we've just set up at the top there. Count plus equals 1, and that says take the value of count and add 1 to it. So all this basically means is that every time the while loop goes round, count will get bigger. So the first time will be 1, 2, 3, hence why we call it count. When it gets to 300, this while loop will no longer be valid and it will stop and it will exit from the while loop. And that means that we'll only record 300 frames, we won't record forever. Now, the main thing we need to do next is to actually get to the accelerometer data. And the accelerometer data is relatively easy. There is there is an object or an item that we can access called accelerometer, and it has 3 methods that we want to use: get x, get y, and get z. These are obviously the x, y, and z directions for the acceleration on the accelerometer. And what we're doing is we're assigning them to x, y, and z values. This just puts them into a sort of local memory so that we can use them later. It just makes it slightly more convenient to write the next lines. Because now that we've got those values, we now want to write them into the file. And so the next line we're going to do is essentially this. So my file.write exactly the same way that we used it here. Only now we've got new values that we're interested in. The first one is the amount of milliseconds that have transpired so far, then the x value, the y value, the z value. Now %i means substitute the value I'm about to give you in here as an integer value. And the first one we're doing is the running time. Now running time basically just tells you how long it has been since the microbit was turned on. And start time is a value that we'll declare in a second, because it would be useful for us to not be from when you started the microbit, but from when this program started. So just before we remove the file, let's just call running time to get the time at the start, so basically the time just after we've pressed the button. That means that our time will start from 0 even if we press the button 3 or 4 times. We then essentially write in the X value, the Y value and the Z value, which we've just recorded from here. Now, with our previous loop, we just let this loop go around as fast as it could, so that we recorded the first button that was pressed as soon as it did. With this loop, we actually want to limit it, and we want to limit it by that poll time that we put in earlier. So in this case, we make use of that sleep command that we used earlier, but we sleep for the amount of poll time. And then essentially this will exit, and that while loop will finish. When the while loop is finished, the with statement will finish, which will close the file will be complete, and it will just sit waiting for another thing. The other thing we can do is we can remove the sleep from the beginning here, because we no longer need that. That was just in place of all of the code we've just written. So now if I save that and flash that to the microbit, so once again flashing light going on the back there. So now we press the button. If we press the button, and I'm now going to hopefully be recording, so smiley face, I'm going to change the direction of this a little bit. Hopefully we'll see this, but it'll be quite nice and polite. So we're still recording. I've deliberately recording this for quite a long time, so hopefully we'll get something quite interesting out of this, and we'll just wait for it to finish. So you can see how long we can record for. I mean, this is sampling at, of course, 10 Hertz for 300 or 300 times. So yeah, so 30 seconds. So now it's gone back to this. If I press this again, my recording will be lost and I'll be freshly recording. But now I can go into my files. I can copy my output.csv across onto my computer again. I go back to the directory that has it. I can then open this file, and now you can see my time followed by X, Y and Z. If I now highlight all of these lines and insert a scatter plot, for example, there we go, beautiful, we will see a lovely chart that shows the X, Y and Z values. So I can't remember exactly which way I moved it, but you can see I was clearly moving certain directions where you could tell a particular direction was the one that was facing down at any one time. You can read into this all kinds of different information. You can then process it as you want using Excel. So this enables us, so basically there we go, that's the completed task. We've now turned our little microbit into a data logger. Now, if you remember what this looks like, the one last thing I'm going to show you is the very important point. So if I now unplug this, hopefully with your microbit you've got one of these power supplies. If you plug the power supply into the top of your microbit, it then runs whatever program was last on it. So I'm going to now do a new recording, and I'm going to try and make it look different to this one. So I'm going to do a recording there. I'm going to hold these guys together, and I'm then going to shake it quite vigorously, because hopefully this will give us some nice alternative signal to the one that we have before. And then I'll give it a little moment of peace. And we should hopefully see something happen on the timeline, and then we'll give it another little shake. Now, the reason I'm doing this is so hopefully you guys can see very clearly that this will hopefully have recorded some lovely new information. There we go, so it's finished recording. So I can now take the power out. Oops, he says, take the power out. But because this is essentially on the flash memory on the chip. It still persists even though I've taken the power out. So if I now plug this in back into my computer, I can now go, if I close this one down, I won't save the output, and go back in here. If I just refresh that to make sure that it's got the right thing on there, it's still connected. I can grab this output.csv and I can put it onto the computer, open this guy up again, double click on here, and hopefully when I insert a scatter plot you will see a significant difference. There we go. You can see clearly the areas where I was wiggling it quite hard, leaving it alone, and then doing these sorts of things. So essentially that's exactly how you would use it. So you would unplug it, plug it into the little battery pack that comes with it, do whatever you wanted to do in terms of the experiment you wanted, and then you can unplug it, plug it back into the computer. It's not necessarily the most elegant system, but it works quite nicely and relatively effectively. So that's basically the end of this tutorial. Hopefully you've all understood how we can basically use our BBCMicroBit to produce a data logger that we can use for the experiments. And the idea of the project that you're all going to do is to essentially replicate this, and I'll give you the information about where this code is so you can just download it and use it. But the main point is to try and extend that. So think about the project that you want to do. Think about how you want to log that. So for example, if you want to do a bottle rocket, 30 seconds is probably too much information or too much time. You probably only want it to be 5 seconds or so, maybe 10 seconds, so you can improve your polling time, or you can reduce your polling time. You can also do more interesting things, like potentially the main limiting factor on the card is the amount of space. So maybe you only log something when the difference between the positions is big enough, or maybe you log the maximum, minimum and mean values of maybe 20 recordings at each point. So you can do all kinds of different things like this to but depending on what kind of thing you're interested in studying. You can also use, so the microbit has it has a compass on it as well. You have to play a little game to calibrate the compass, but you can do that before you start recording. That allows you to sort of show direction, but also it's got these tabs at the bottom, so you can connect other sensors to them quite happily. So you could I believe at least you can connect things like a temperature sensor or something like this, or a light sensor if you want to do a different type of experiment with other electronics kit that you have available to you. The main thing is that you can choose whatever type of experiment you want to do and just log it with the microbit. Hopefully you've got all the information you need. If there's any problems, just contact me and I can give you some additional help.